Still in 10.6. The next thing is the remainder in an alternating series. And if you read through the material in the book, it turns out if you're trying to find the remainder after n terms, you would take the actual sum and subtract the n terms. And what's going to be left? Well, it's going to be, if I take the next term and subtract that term, it's going to be less than that, which that's actually the next term. So it should make sense to you, since they're alternating, that if you stop at the fifth term, the biggest error is going to occur when you get to the sixth term, because that's going to be the next error that you're going to add to it. So example 2 wants us to look at how many terms in the series natural log of 2 all the way out, and they gave us the summation, -1 to the k plus 1 over k, are required to approximate the value of the series with a remainder less than, or remainder's got to be less than, 10 to the -6. Okay, so, oh, and there's two parts to this, an A and a B. Yeah. So this is part A. All right, so the remainder is going to happen at the next term. Well, the next term is going to be, if we take it out to the nth term, then the a sub n plus 1th term is going to be 1 over n plus 1. You don't talk about the alternating part, you just talk about that. So we want to know, when is this term going to be less than 10 to the -6? Which means that n plus 1 is greater than 10 to the 6th, which means n has to be greater than 10 to the 6th minus 1. So 10 to the 6th, that would be 1,000,000 terms to have a remainder less than 10 to the -6. And then part B, if n is 9, the terms -1 plus 1 over 2 factorial minus 1 over 3 factorial dot 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 out to the summation k equals 1 to infinity -1 to the k over k factorial are summed. What is the maximum error committed in approximating the value of the series, which is e to the -1 minus 1? That's what the actual answer is. Okay, so if I'm taking it out 9 terms, then when n is 9, you get, it'd be -1 over 9 factorial. The next term, a sub n plus 1, which would be a sub 10, would be 1 over 10 factorial. And so the question is, the remainder after 9 terms would be equal to, I'm going to write out the whole thing, s minus s sub 9 less than the 10th term, and that's 1 over 10 factorial, which if I put that in my calculator, it's 2.8 times 10 to the -7. So the maximum error is approximately 2.8 times 10 to the -7. If you go and you put in your calculator the summation and you add them all up, you get -0.6321 stuff. And the actual answer, oh, I got to write all the stuff, 0.632120811 is what you get when you actually add up the 9 terms. And if you figure out the real sum, the sum is going to be e to the -1 minus 1, and on your calculator you get -0.632120559, which, if I subtract them, it's about 2.5 times 10 to the -7. So we are underneath what they're saying. All right, that's the maximum error because that answer came out under. The next thing is absolute convergence. We're talking about the difference between absolute and conditional convergence. And it says in here, assume that you have a series that converges. The series converges absolutely if you do the absolute value of it and it converges, if this guy converges. Otherwise, it just converges conditionally. So you can say it converges, but if you do absolute convergence, that's what you have. It converges absolutely if the absolute value of the summation converges. And if it doesn't, and it was a convergent series in the first place, then it's just called conditionally convergent. And then that means that if you have absolute convergence, then that implies that the original series was converging in the first place. If the series diverges, then the absolute series would also diverge. So let's look at number 3 and see if I can fit these all on the same page. 3a, we have the summation k equals 1 to infinity, negative 1 to the k plus 1 over the square root of k. It says, determine whether the following series diverge, converge absolutely, or converge conditionally. So if I look at the absolute value of this, it turns into the summation k equals 1 to infinity 1 over the square root of k, which is k to the 1/2. That's a p series where p is equal to 1/2, which is less than 1, and that means that diverges. So if that diverges, the alternating series does not converge absolutely. If I want to decide if it converges conditionally, we have to look at the original series with the alternating signs. Do they decrease? Yes, they do decrease. And if I take the limit as k goes to infinity of 1 over k to the 1/2, it does go to 0. So by the alternating series test, it converges, it just converges, but not absolutely. So converges conditionally. Can't converge absolutely because when I did the first step, it was a p series and that diverges. That one diverges. Part B. Summation k equals 1 to infinity, negative 1 to the k plus 1 over the square root of k cubed. Okay, if I do the absolute value on that one, summation k equals 1 to infinity, 1 over k to the 3/2. Again, it's a p series. P is equal to 3/2, which is greater than 1. So it converges. And since we were doing it with the absolute value, it converges absolutely. That's absolute convergence test. And then part C, oh, there are D parts. K equals 1 to infinity of sine of k over k squared. If I do the absolute value on this one, okay, they don't strictly alternate sign. The first few signs it's not alternating, because as I put these in, they're not going to alternate back and forth. It does something weird. The first few are positive and then it goes negative. So the alternating series test does not apply. Since I know that the absolute sign of k is valued between 1 and negative 1, I could say that's always going to be positive. This is going to be less than or equal to 1 over k squared, which is a p series. 2 is greater than 1. Oh, goodness. Greater than 1. So it converges by the comparison test. So I'm comparing it to 1 over k squared. 1 over k squared converges, and it's less than that, so it converges. And since I started with the absolute value on this, it converges absolutely. And then part D. K equals 1 to infinity. We have our negative 1 to the k. That's interesting. It's going to start out negative. Times k over k plus 1. I could do the absolute value on this, but if I just look at the limit as k goes to infinity of k over k plus 1, that gives me 1. The terms of the series are not tending towards 0, and so by the divergence test, it diverges. Yeah. Because if the limit's not going the right way, it's supposed to be heading towards 0, and it's not heading towards 0. All right, this concludes section 10.6. 10.6, the last page in that group has a whole chart for you on all the different tests that we've talked about and how you can apply them. I've also put my version of it